Okay, so let's look at factor analysis in R. The network is not too good. Just bear with me. So I'm sharing my screen. My screen is going to have some challenge. I pray that I'm able to finish it. Okay, so let's look at strings. So today I'm trying to look at strings. A string is like a set of characters that you print it out. Going to have the same thing. I can also and then I'll use single quotes like this, and I say, uh, let's say I say data science is very important, and so I can just leave it at this point. And so when I do that, it will print exactly what I have done here. That's what strings do. Now we also have what is it? Other strings here, like I've already demonstrated, and then as you can see. So now when we come to, for instance, let's say I love fufu. So I could actually just put the words one after the other. I love fufu. Then I could add here, let's say D, and then the D I can just say and S, and then I'll just put it also over there, and then light soup. They have to be in something like light soup. So this should have been like this. So when you have it this way, you can actually, put all of them together. Here I could have added D, comma, and then S. So when you print that, you're going to have, okay, I need to run all of them at a go like this. And so when I come to print this, it's simply going to pick the values or the strings I have assigned to these values as these variables A, G, D, and S. And then it will simply print them out. So I love fufu. The second one, it will tell me that okay, I need to have some S here. That's what is happening. So when I do that, it will simply take out the separate. Yeah, I love fufu and then light soup. And I decided to use the separator dash as my separator. I could have equally used the no separator. And in that case, you see that you just print everything as one word. And then that's what we normally do. Sometimes you may also want to, like for instance, you want to print and then you want to collapse some kind of thing there. So I love fufu. So the separator, I have collapsed it. There's no separator again. And so, of course, there are instances we also use other functions like format to be able to deal with our strings. So, for instance, if I say format digit 9, it means if the digits were so many and I just want only 9 digits, I'll use the function called format and then it will print only 9 digits for me. If I do that and I come to print results, you'll notice that it prints only 9 and ignoring the others. So here I can use scientific, and then that is going to also print some values for me. So the scientific, if I print the results here, you notice that it's going to give me this output. The same way as we have here, you can format it and small, and then you have your results also printed out. Now you can change the whole of a string to an uppercase. For instance, if you have written a whole lot of things and you want to change it to uppercase, then you can simply do that. So let me try and see if this will, so you see that it changes everything to uppercase. Now remember we had a data frame. So let me do it this way. There was this data frame that we had here. You see, so if you notice, you will see that I have this particular last column, which is called status. You see, and it's made of characters. Let's see whether we can change all of them to uppercase. So, for instance, if I do this and I bring this, it's going to add the dollar sign to it. It's going to bring this out. And so if I run it, it's going to print only this. What about if I put here to upper like this? Then I put that into bracket. I put the whole thing into bracket like this. So it means that I'm going to use this function and I want to change the status, which is all of them there to uppercase. Run it. So you notice that everything, the status is now uppercase letters. And that's how it is. Maybe I should try with another one. Okay, I can come here and say to upper. So if I do like this, you put the data frame inside. Okay, this is another data frame 2. So if I put dollar, I'm going to have this. So the names, let's try and see. The names, we have numbers attached to it. Whether it can be changed to uppercase. You notice that it changes. So it will change everything to uppercase letters, as you can see them here. That's one of the functions of how to be able to change from uppercase to lowercase and then stuff like that. Now, let's assume that I wanted to, let me see that, okay, I want to change the first 10. 1 is to 10, and then run it. So I'm not looking for all of them. I'm just selecting only the first 10, and then I'm changing them to uppercase letters. So that is how it works. So we can go on and on, change uppercase, bring them back to lowercase, and then whatsoever. Now I always say that after you've run a function, you can actually pack the results if you like it. To show you create a new variable and pack the results there. So there are instances too, you have something we call substrings. The substrings allow you to be able to isolate or to pick a portion of the string. So let's assume that I have this my name. My name, because they're characters, I put in inverted comma, is a string. But I'm not looking for all of them. Maybe let's say I want from, I just want to pick some letters from there. So here I'm picking from the 3rd letter to the 5th letter, with the 5th letter excluded. So if I run that, and then I come to print the variable called dd, you notice that it's going to print IGB. It will start counting from the 3rd letter, then followed by the 4th, and then the 5th, and that's it. So the 3rd, the 4th, and the 5th, and then to print that out. When we come to something like contemporaneously, it starts from, and then out to print the letters, that is from 2 to 7. You do that, and then I come to pick this extract out. I come to run the extract out here. You will notice that it starts from the 2nd letter, which is here. And so I have 2nd, 3rd, 4th, 5th, 6th, 7th. So that is going to give us 7. Okay. And so the substrings always allow us to be able to extract. And this is very important when you are designing like a game. You use some of these functions to be able to do that. Now, another substring here, the substrings are not only characters. As long as you put any number in double quotes, it is seen as a substring. So let's see, this was the whole numbers we have. wanted to subset some part of the numbers, we can use substring to isolate those numbers out. So you just need to specify the positions. You use the substring followed by the string, and then you specify first position to the. So if I run this, you notice that it's going to print up to some point. What about if I run only 4 without anything, and then I come to print it? So it will start printing from the 4th position to the last, because I've not indicated the last, so it will print to the last one. And so that's what has happened here. So if I also if I want to print the same value, I will say 4 and then another 4 like this. So it will print only one value. So if I come around here, it will print only one value. That's how to print one value. Now, these are the various ways through which you can extract some of your substrings. So you have a whole string, and then you can isolate some portions of it. Like I already told you, I have a serious scatter. So excuse me. So, sorry about that. So let me come back, and then so that is it about strings. It actually allows us to be able to do one or two things: uppercase, lowercase, isolate a particular string, and then in that order. So if you also wanted to what about if you have a whole vector, which is a string, and then you want to isolate some kind of values from there? Check that out. Now let's look at factors. Factors are very important in data analysis. A factor is simply like a string, but what is it? Is a string that has appeared more than once or even once. So when you see all these things we have here, I just created a vector of east, west, then in that corner, north, from whatsoever. This particular data I have created here, if I pack everything to this place, it's just a data. All right. So I have here, if I print it, you're going to see east, west, east, north, and whatsoever. But how will I know the number of times each of them has appeared? So we use factors to be able to do that. You convert the whole strings into factors. And when you do that, it allows you to be able to measure the number of times each of the string has appeared. So to do that, you use a function called as factor. So now we've already packed the data into, we've already packed the whole of this string, which we use the concatenate function to create. And then we put it into data. Now, after we've done that, what is the next thing to do is to convert it into factors. Create a new variable, convert the whole thing into factors, and then pack it into that particular variable. So we run this as the new variable. We run that as our new variable, and then when we do that, we can now have what we call factors. So now, because we run this, so we've converted the data, which were only strings, into a factor. And now, if it is their factors, we can now look at the labels. The labels means, if you look at this, even though you have east, west several times, but the labels are only 3. The 3 is what? East, north, and west. So it means there are these 3 things which have appeared many times, and that's all. So the labels will simply tell you what is the different all those strings. I mean, in total, how many are they? And then that's what we are talking about here. Let me check something here. So if I have if I have converted everything into factors, then I can actually have a view. I can actually visualize it. For instance, I can simply say, maybe let's say a bar plot, and I'll put data underscore, okay? And then I'll plot it. Height must be a vector. All right, so I cannot use that plot. So I can possibly use ordinary plot. And then it tells me that height must be a vector. I think there's something wrong somewhere. It can work. Yeah, it has worked. So let me check bar plot and see. Okay, so bar plot will not work with it. Bar plot can work with it. So look at how it looks like. So we now have east, north, and then west. And this is how we are able to make sense from the factors. Now, we can also create the factors and change the factors, the levels in which they are. If you check this first level, we had east, north, and west. But we could actually allow the north to come first before the west and then the east. And then what we simply do is we create a new variable and come and say factor. The same factor that we are using here, we are now saying factors. Then we use the factor data that we're already having, data underscore factor, and we now say levels. Then levels is equal to, then you use the vector sign to the way you want the levels to be. Then you arrange it here, and then it will create the new levels for you. So now, if I plot this, that is going to give me a different plot. Oh no, it's going to give me the same plot. But if I put something like new underscore data like this, if I plot it, you know that it has changed. We now have north, west, and then east, then in that order. Sometimes you want to find out whether the data is factor or not. You use is dot factor. You are just asking whether it is a factor data. If it is, it will return true. If not, it will return false. Data itself is not factor, but data underscore f was factor because we converted it. This is how we look at it. Now let's look at application of factors in R. So we have a data called gender, right? So I'm just going to run this particular data. Remember this, my data 3. If I run it, you can see I have a column there called gender, well, which I call it sex. Yeah, it's actually sex here. So now we are selecting that particular column and we pack into a new variable called gender, which I have here. I run that. I want to now convert that gender into factors. So I'll say as factors, put into bracket gender, and pack everything to the same variable. What I'm simply doing is that the gender variable I created here, I want to replace it. So if I run it, it will replace the old one with a new variable or with a new object, which is factors. So now if I come here and I look at the levels, you can see I have female and then male. So if you want to know a portion of males and female, you just plot it. I can just put a plot there, and then I'll just say I'll put the gender there like this, and then it gives me the gender. So you can look at the female as well as the male. This is how, so sometimes some people will look at, let's say, a box plot, and then let me try this and see. So if you look at a box plot of it, because the box plot is actually used for data distribution, even though you can visualize it, it will make sense to you because the data is too small. So we use just plot, and then that is it. Data visualization is going to be a whole topic that I'll be dealing with. Now, much more of where we apply this factor data is when you have gone out to do an interview. So let's look at what interview can we come in mind. So you've gone out to sample 1,000 views about what they think about nutrition. is nutrition a good cause? Or you've gone to check to pick some data about people's perception about data science. So yeah, it's going to be perception about data science. So I'm going to create a variable called perception, and then give me a minute. So let's look at, we want to look at people's perception about data science. And so I just created a new variable. I'm just going to say, so I'm going to sample people's views. So what are some of the things that you'll be looking at? So your objective, you would have said that data science is good. It is not good. Well, it is all right. Or you want to look at whether data science is impactful in Ghana or not. So what I'm going to say, I'm going to sample, we are going to sample, so we create a vector and put the variables there. I'm going to create a vector, and then the first variable we are going to say is data science useful in Ghana? Some will say yes. Others will say no. Others will say, okay, S underscore how. That means somehow. Others will say don't know. And then in that order. Let's leave it this way. So we want to sample from this particular vector. And how many are we sampling? We are sampling from 1,000 people. So, and because we are sampling from 1,000 people, we do a replacement of true. Some of them will pick yes, yes, yes. Others will pick no, 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 no in that order. So we have created a vector like that. If I come here and I print this is what you are going to see. You see? So this is the kind of data you're going to collect. When you collect it, when you come, you know that these are factors. You need to make sure they are you need to make sure that you convert them into factors. So what are we going to do? We are going to say that so we're going to have perception again, and this time around perception underscore 1, because we are creating a new variable, and then we convert it into factors. So we say as factors, and then we put into brackets what? Perception. That's what we are converting the perception into factors. When we do like that, we've done that. So we can come here and now say is dot factor, and then we put the perception 1 there, and then check to see. When we do that, we notice that the perception 1 they say is true, they are factors. We could check and then look at the levels. So I'm going to say levels, and I'm going to have perception 1 here, run that. How many levels do we have? We have 1, 2, 3, 4. There are 4 levels. So in that case, we can have a visual impression of what they are. We can actually say, then we plot it, and then we put perception, we put the factor 1, which is perception 1, and then maybe we can give it a color. Colors are always put in inverted commas. We can give it a color green. And green, all colors are spelled with lowercase letters. Now, when we run that, it's going to give us the perception. And this is how it looks like. Well, so when you do this, it means that something... oh, I've mistakenly closed my arrow. God. I think this is the kata. Okay, I'm sorry about that. It's loading. We're done momentarily. Okay. So I'm just ignoring updates. Look like the font size is just too small. So let me come here And then I'm going to say appearance, increase the font size to 125. A little bit is better. So, and then I'll escape this. So this is where we were. So we just created that. We changed it into factors. We asked the levels, and then we decided to plot it. So when we pick this out, you can now see how it looks like. So those who say they don't know, look at the plot. Those who say they know, those who say somehow, and then those who say yes. This is how to make sense from your own factor data. You can try this in many ways. And then you will see that, I don't know whether scatter will work with it. Maybe scatter smooth. I don't know whether it will work with it. Perception, I'm not too sure. No, it will not work because scatter plot works with X and Y axis. Here, it will not work. Maybe let's check for box plot. Let me see whether box plot will work with it. So I'm going to have perception 1 like this, and then try and see. So the box plot is trying, but you will notice that it's not too. Here we have the whisker, and then we have the median, the maximum, and then whatsoever. I'll be doing data visualization, so I'm going to be talking about it extensively. So this is how we are able to create factor data, and then we are able to work with it. We can actually count it, and we can visualize it, and then it's very important. Maybe I should do one more, and then let's go. So what you need to know is that data science is much more tricky. What you have to know is that you have factors somewhere, and then you just want to make sense from it. I've already said that a factor is like a response. Like responses, you want to measure the number of times that response has been recorded. For instance, if you go to a hospital setup, and then you want to find out the number of times people have recorded malaria, or the number of times a particular community has visited that hospital. You see, you can always look at that, look at the number of times it has appeared. You count the number of times, and that's it. So what you normally do is you put the data into kind of factors, you convert everything into factors, then you have levels, and then you can visualize the level. Arrow will automatically count the levels and then tell you. And that's just about it. To be able to plot it or to have a very good plot, one of the plots you can use is bar plot. I don't know whether histogram works with it. Histogram of perception. Obviously, histogram is about data distribution, so histogram will not work with it. What about bar plots? Let me check bar plot and see. And then I have perception 1. The bar plot will not work with it. So you just use the inbuilt plot called plot function to be able to visualize it. In any case, I'll be talking about data plotting and then data visualization maybe next week. So we're going to be doing that. Now, this is the last example I want to give, and let's pay attention. So let's assume that we've gone to look at KNUST students, and we want to measure a particular characteristics of the students. As to whether those who are regular in class and those who are not regular in class, and then whatsoever. I'm just looking at some example that will be much more convenient. So, or you want to check malnutrition. So I just want to say what is group status. Group underscore status. Please create variables whose names ring a bell. And here, because I'm creating ordinary sample data, I can always sample from a vector. So I'm sampling from more than one thing. So what I'll simply do is I can do something like this, and then I would say what is it? Underweight. So I have underweight. I can come out and I will have stunted, or yeah, stunted. I don't know what other variable is there. I know we have underweight, we have stunted, we have let me just say let me just say none. Okay. So this is how you always. So this is the what you are coming out with. So when you finished, the sample is out already. Then you now come here. How many are you sampling? Let's say 1,000. And then replacement. Remember that replacement should always be true when you are sampling from a very small population. So replacement is equal to true. You run that, and then you notice that you're going to have your data. This is how it's going to display. So if it display like that, what will be the next thing? Convert it into factors. And so if I say group status, if I want, I can still maintain the same thing and then convert it into factors and make sure that it will replace the old one. If you don't want it, if you want to keep the two, then you add one to this, and then it will be a new variable. So I'll just do this, and I'll say as factors, and then you now put this variable you have created, group underscore status, because that's what we are now converting into factors. So I'm going to have group underscore status and then do this. That way it becomes a factor. So this time you don't have to check the levels whatsoever. So you can just go ahead and then plot it. So I'm going to plot group so we are plotting the one here around that. So there are only 3 factors, and then we can check how it looks like. You can add your color whatsoever, and then you are able to do comparison. This is very necessary because very soon we'll be, if we are looking at the different data set from different places, that's what we may have to look at. Very last example, let's assume that a CCTV cameras were mounted in some places, and then every 5 minutes the camera capture maybe an image. So let's assume that we are going to, so what I'm going to do is I'm just going to say CCTV. That's the variable name. And then I'm just going to come here and then sample. Okay. So I'm going to sample from here, and I'm going to use C. And then the C, the object that the CCTV cameras have captured. Maybe it would have captured a car. Move out from there, it would have captured motorbike. It would have captured something like a tricycle. It would have captured something like what? Car, motor, tricycle, like human. Or I should have said adults. Yeah, I should put here adults. Oh, sorry about that. Then the camera too would have also captured like child. And then maybe it would have captured animal. So you are checking how many times in total captures do we have. So we notice that maybe let's say there were about 2,000 or 3,000 captures. And so replacement is equal to true. When you run that, your CCTV cameras are ready, and then you can see that this is how you are going to get the data in real time. In real time, this is how you are going to get the data. You see that has captured different people at different times up to. And so what do? The next thing is to convert it to. So I'm going to say CCTV underscore 1, a new variable, and come here, and then I'll convert the old one as factors, and then I'll say CTV and run that. So I've converted it to factors. The next thing is to make sure that I plot it to have a visual impression. And so I'll simply just say plots, and then I'll put CCTV underscore 1 here, and then plot it. Maybe I should give it a color. And the color will be, let's say, red. That's it. So if I come here, so you can look at the number of times each of the CCTV cameras have captured an adult. It means that on KNUST, the CCTV camera capture cars more than it captures. What's the least thing that it captures? Children. As you can see, it captures children, the least. That's the least captured. And then what it captured most is cars. As you can see, it captured cars most. Now, the next time, I will show us how to be able to specifically analyze each of the camera's positions. And then I will do something we call group bar charts. And then you look at each camera and how each of the camera's positions were actually, so we find out which particular camera position captured more of a specific object as compared to the other object. And this is how we can apply factor analysis in data science. So you see adults, it captured more adults. Of course, KNUST does not have much more children. So as you can see, it captures cars more because we actually have buses that transport people all the time. People who are not moving. And then it captures adults, the second highest. Before, even though I was expecting that, obviously when we are talking about animals, animal will be very small, but because this is simulated data, that's why you have it this way. So this is how to be able to make sense from, let's say, a data of that sort. Maybe we could have, if I had done a box plot, and then I put CCTV 1, let's look at how the distribution would have looked like. And then here, I'm going to give a color like this. I'm going to say that color should be blue. Blue like this. Run it again. So this box plot. So we can look at the CCTV camera footages and then the box plot and how. So this whisker tells us where we have the maximum. And then this is the minimum. Here is the 25th percentile. Here is the 75th percentile. And then this is the median, which is almost the same thing as the average. So here, and anyway, I'll be talking about data how to be able to interpret your data after you have plotted it or whatever analysis. So, but this is how we make sense from factor and analysis, and it's very important. So if you always have to convert it into factors, I've shown you how to be able to convert the table's own into factors. You just simply specify the column, then you specify which area of the column that you want, then you can just do your factors there, and then you put your analysis alongside. These ones are very simple things that we are doing. We'll get to a much more complex graphs, and then we'll see how it works. But don't worry, it's a gradual process. Right, so thank you from somebody who is often from Qatar. But what is it? I will upload a video as soon as possible. In the case you have anything you don't understand, please allow me to explain. Thank you. Bye-bye. Okay, so I will leave it here, and thanks for being around.